Alright, had a lot of questions about this assignment, so going to go ahead and make a video for you all to watch, make sure we're really understanding what's going on here, not having any issues, so on and so forth. So first step, label the sides of the chemical formula as reactants or products. So we know from our notes last week that in a chemical equation, you have reactants and products. Basically, you have two types of chemicals that mix together and start the reaction, and those are called the reactants. They do the reacting. So this left side right here, the first two things you start with, the left side shows reactants. And then what happens is those reactants combine to produce what we call products. Products get produced. All right, so reactants and products. Again, that's important to know because you just need to be able to talk about a chemical formula and understand, what molecule is part of what. So, looking at this same chemical equation from the previous slide, we're going to be counting how many atoms of each element are in the reactants and are in the products. So basically, we're going to do counting atoms like we had been all of last week, but this time we're going to put it in the lens of a chemical formula. So in the reactants, which means I'm only counting this left-hand side over here, I'm only counting this side. Sorry, it's hard to draw with a mouse. We're only counting that side. How many atoms of hydrogen are there? Well, I've got a coefficient of 2 in front of H, and I've got a subscript of 2. So what I'll end up doing is 2 multiplied by 2, and that will give me my answer, my total number of hydrogens. So 2 times 2 equals 4. All right, now let's go to the next page. So in the chemical equation below, how many atoms of oxygen are in the reactants? So remember, I'm only looking at this left-hand side because that's my reactants. My reactants have oxygen right here, and I see there's no coefficient and just O2. So that means 2 atoms of oxygen. Another way I could be doing this is visually and looking at how many literal atoms there are. So if the atoms are being represented by these circles, how many red circles are there? Well, there's 1, 2. Great. Okay, now we're going to do the same thing, but on the products side. So let's take a look here. How many atoms of hydrogen are in the products? So the products are right there. Sorry, got on the whoops. I want to go here. My bad, got on the wrong slide. So how many atoms of hydrogen are in the products? Hydrogen, I would do coefficient of 2 multiplied by subscript of 2. So that gets me 4. If I wanted to use the visual method I just mentioned, I see 1 blue circle, 2 blue circles, 3 blue circles, 4 blue circles, 4 atoms of hydrogen. Okay, what about oxygen in the products only? How much oxygen is in the products? Well, visually, 1 red circle, 2 red circle, so I think 2. But if I'm going to do the atomic math, I would take the coefficient of 2, multiply it by the subscript of 1. 2 times 1 is 2. So the products have 2 atoms of oxygen. Great. Is there the same amount of hydrogen in the reactants and the products? All right, so we can look back at our previous answers, or we can just do it again right here really quick. In the reactants, I see 2 times 2 is 4. In the products, I see 2 times 2 is 4. So, yes, 4 atoms of hydrogen in both. Great. This slide is going to ask the same thing for oxygen. So the same amount of oxygen in the reactants and the products. Well, let's see. I've got 1, 2 right here, and I've got 1, 2 right here. So it seems like it. Yeah, seems like yes, there is 2 atoms of oxygen on each side. All right, great. So looking at this last question, does this chemical equation follow the law of conservation of mass? Are any atoms created or destroyed, or do they just get rearranged? Well, we had the same amount of hydrogen on this side as we did on this side, and we had the same amount of oxygen on this side as we did on this side. So the answer would be yes, it does follow the law of conservation of mass. And what that basically means is this equation is balanced. All right, this equation is balanced, and what that means is that we have the same, sorry, my dog's barking in the background, means we have the same amount of every type of atom on the reactant side as we do on the product side. So I hope this helps with this first part. Let me know if you have any other questions.